Yeah.
Happy Thursday. Okay. So today we are going to go over a few questions from last night's homework. So go ahead and get that out. I am making comments on your assignment. So the past few days I've been commenting in Google Classroom to make sure you're checking the edited version, just to remind you that there are edits, but just be aware that there are edits on the document. So make sure you check that out because we do take the time to give you feedback on the homework.
Yeah, this year, more than any other year, you should be getting a lot of feedback on your homework because teachers aren't just walking around and checking your homework in class because that doesn't exist. But instead, we're collecting it and looking at every assignment. So we are taking a lot of time to do that for every student that we teach. So please look at the comments that are posted for you because that's like the way that you're going to get feedback from us and also kind of learn and understand the concepts that you're not correctly working through. Really important process of learning math is to look at your mistakes and the feedback you're getting from the mistakes.
Yeah. So we're also going to learn our last way to solve quadratic equations, which is using the quadratic formula. So we're going to learn that today, and we're also going to talk about something called the discriminant to help us determine how many solutions an equation has. Your book homework is right down here. It's numbers 3 to 35 odd. Make sure you're writing those down correctly because I saw a few students do 3, I think it was 1 to 27 odd last night, and a few students did 1, or maybe it was the other night, did like a bunch more problems than you needed to. So make sure you're copying that down right. And looking forward, your sections 4.3 to 4.8 test is Tuesday. Tomorrow we will be reviewing, Monday we'll be reviewing, and Tuesday is your test. So today's the last bit of new information you're going to get. And then we will review, and then test. So get that homework out. We are going to look at a few things on there. Let's look at number 30. Number 30 was 4x squared minus 40x minus 12 equals 0. So we are completing the square here. The directions said to complete the square. So Annabelle, what am I going to do first?
I divided 4 out from the terms.
Yes, we will. But before we do that, we have one thing we should do first.
You move the 12 to the other side.
Yes, awesome. We want to move that 12 to the other side. So I'm just going to do that in 2 different steps for right now, just to emphasize that we need to move that C over. And yes, you are correct. Next, we're going to pull that 4 out. So then we get x squared minus 10x equaling 12. Ava R., what are we going to do next?
Next, you do 10 or negative 10 divided by 2 squared, which will give you 25. So you plug that into the parentheses, but then to put it on the other side, you have to do 25 times 4.
Yeah, awesome. I want to see this step in your work. This step is important to show. Show what you're adding inside the parentheses, and then that also makes it very clear what you need to add to the other side. We see we pulled that 4 out. We need to add 4 times 25 to the other side. No skipping this step since we just learned it. We want to be very explicit with our steps here. This will also help you not make mistakes. Awesome. All right. Ava M., what does this become now? What can we do?
You can like factor it, and then it'd be x minus 5 squared with the 4 in the front.
Awesome.
And then it equals 112.
Good. Faith, what should we do next?
Divide 112 by 4.
Good. And what will that give us?
28.
Awesome. What should we do next, Faith?
You should take the square root.
Mm-hmm. Good. So now we have x minus 5, and what do we get on the right?
2 to the square root of 7.
Is there anything else we need with that 2 root 7?
Positive and negative.
Yeah. Good. And then what's our last step, Faith?
You take -5, or you add 5 to both sides.
Yeah. So I am writing this step because I saw on the homework a lot of this, translating that 5 over and forgetting you're doing the opposite sign. So we're adding that 5 over, so this 5 is positive. It's a very simple little mistake to make, but just make sure you're being explicit and showing what you're doing to add so that you get the right answer. Good. Questions on this? All right. So then for 41 to 44 and 47 to 49, the direction said to write the quadratic equation in vertex form. That vertex form is what we talked about lastly at the end of class yesterday. This is that form. And we'll talk more about this after Thanksgiving break. We're going to dive deeper into that. But who can tell me what the vertex is from that form? Remember what the vertex is? Jaden.
Isn't it h equals the x and then k is the y?
Yeah. So that minus sign is part of that equation. It's part of the formula. So our x value is h. So I saw, we can look at an example. So let's look at 43. Y was x squared plus 12x plus 37. And we're still doing the same thing. We still want to complete that square. So we're going to set this equal to 0. We'll bring that 37 over. We know we need to take that b, which is 12, divided by 2 and squared. That gives us 36. So we get to here. Ella, what does this left side of the equation become? Can we make that into a binomial squared?
It would be x plus 6 squared.
Yeah, awesome. And minus 1. So to get it into that form, all we need to do is bring that -1 back over. Get everything on the same side again. So that vertex form looks just like that. So then Gabby Snyder, what would our vertex be here if we just talked about it right there? If our vertex is HK from that formula, what would it be for this problem?
Would it be 1?
So it's an ordered pair, you have x and y. So our h is there and our k is there. So that formula had a minus in between. So this is really like a minus and negative. So that vertex would be -6, 1. Because that formula had a minus in between there. So that's technically like a -1 is that x value. So that's what 41 to 44 and 47 and 48, that's how they asked you to write your answer. A lot of you continue to solve for x. So that would be the same way we solved the beginning of the homework, but just make sure you're reading directions to see how they're asking you to write your answer. Any other questions? Very important to show this step. We want to see that step, what you're adding to both sides. Okay. So now I am going to, let's head over to our notes. Page 23. So this is another way that we are going to solve quadratic equations. If we can't factor it, we can't take the number in front of the coefficient out evenly and complete the square. We can't use square roots. We are going to use the quadratic formula. So that formula is x equals -b plus or minus the square root b squared minus 4ac all over 2a. I'm sure your faces are like, oh my gosh. Well, let me just switch what I'm sharing real quick. This should help us.
X is equal to -b plus or minus the square root of b squared minus 4ac all over 2a.
So this should get stuck in your head by the end.
X is equal to -b plus or minus the square root of b squared minus 4ac all over 2a. X is equal to -b plus or minus the square root of b squared minus 4ac all over 2a. X is equal to -b plus or minus the square root of b squared minus 4ac all over 2a.
All right, so hopefully that is cemented in your head a little bit. I wish I could hear your voices at 7 a.m. singing this song. That'd be wonderful. So that is our formula that we are going to use if we cannot solve this quadratic any other way. This will always get us an answer. This formula will always get you an answer. So the discriminant, that is going to help us determine how many solutions we have. That is this part right in here. That b squared minus 4ac. And we'll talk about that, what solution you get and what that means. So it says the quadratic formula, let a, b, and c be real numbers such that a can't be equal to 0, and the solutions of the quadratic equation ax squared plus bx plus c are, and that is what's right up there. That's our quadratic formula. So now we're going to use it. Example 1 says solve x squared plus 7x equals 6. Now we need, what do we need from looking up here? How is this equation written? What's different between the way ax squared plus bx plus c is written and this x squared plus 7x equals 6? Helene, what is different?
The C is on the other side of the equal sign.
Yeah, so we got to bring that over. So let's go ahead and do that. We need everything on the one side to be able to use this formula. So let's think. Our a is the number in front of your x squared. What is that? What is our coefficient in front of x squared, Julia? What's that coefficient?
1.
Yeah, and while I have you on, our b and our c, what is our b?
The B is 7 and our C is -6.
Yeah, so now we have our a, b, and c. Now we can use that formula. So I'm just going to rewrite it down here. X equals -b plus or minus square root b squared minus 4ac all over 2a. That song should be replaying in your head right now on the back of your brain. All right, so we have -b plus or minus, we're just plugging in those numbers that we just found. Square root b squared, so that's 7 squared, minus 4a, which we said is 1, c, which is -6, all over 2 times a, which is 1. So now we're going to continue to simplify. We can't do anything with this -7 out front. Let's work inside these parentheses. Grace, what is 7 squared?
49.
Good. And then we have -4 times 1 times -6. Grace, do you know what that is?
Would it be 24?
Yeah, and it's going to be positive. This is where it's important to look at your signs. The 4 is a negative and the 6 is a negative. 2 negatives make a positive, and that 1, anything times 1 is just itself. And this is all over 2. So let's keep simplifying. We have 49 plus 24. That gives us 73 all over 2. And can we combine anything else? Do we have any like terms? No, we don't. And so this is our final answer. Mrs. Kane, is it okay to write our answer like this, or should we split it up into two fractions?
They can keep it like that.
Okay. And we will not be going through and making that square root a decimal. We do not want decimals. We want to keep that answer. Okay. Now see how this said this equation has 2 real solutions? We're getting 2 different solutions because the one is the -7 plus root 73 over 2 and the other one's -7 minus root 73 over 2. We can take the square root of positive 73. It's not imaginary or anything. That will just give us a decimal. So we have 2 real solutions there. Now let's look at example 2. They're saying solve an equation with 1 real solution. Well, let's see what they mean by that 1 real solution. So we have our equation here. Lacey, can you tell me what our A, B, and C are here?
Would it be 25, -30, and 9?
Yep. Awesome. So very important to bring the sign in front of the number with it. And we know the formula, so go ahead and start plugging into that formula. Notice we have a negative b. So if we have a negative and negative 30, that'll be positive. So that's what this looks like once you plug all those numbers in. We know a negative and a negative will give us a positive. 30 squared gives us 900. And Riley, what do we get when we get -4 times 25 times 9?
I think you would get -900.
Yeah. So 900 minus 900, that's just 0. Square root of 0, that's just 0. So now we just have 30 over 50, which is 3/5. So x is just 3/5. Notice how we got 1 real solution. All of the numbers we plugged in that square root just went to 0, which leaves us with 1 solution because that plus or minus belongs to the square root. So if that's 0, we're just going to get 1 solution.
Miss Carp,
Yes.
I'm sorry, can you explain the difference between number 1 and number 2?
So the only difference that I'm talking about, we're still using the same formula. The difference I'm talking about is what type of solution we get. We're going to talk about this again in a second. So it's involving the discriminant. So what is inside here in both of them? In the first example, we ended up getting a positive number inside that square root. And when we get something inside that square root, we're going to end up getting 2 different solutions because we have that plus or minus. Oops.
Oh, okay. Do you
Yeah.
have to write it out? Or is that what Miss Kane was talking about, that you can leave it like that?
Yeah, we can leave our answer like that in number 1, but we know that there's 2 different solutions, right? Because of the plus or minus.
Right, okay, that makes sense. Thank you.
Yeah, you're welcome. And we'll touch on this again in a second. All right, so now let's look at example 3. Zach, can you tell me what our A, B, and C are here?
A is -1, B is 2, C is -5.
Yeah, see, I was tricky there. Just went right to writing down A, B, and C. We got to bring that, that 5 over. But Zach knew. Zach caught the mistake. All right, go ahead and use the quadratic formula. Once you plug all your numbers in, inside this square root, we should get 4. And then -4 times -1 will give us +4. Then 4 times -5 will give us -20. All over -2. So here inside that square root, we'll end up getting a -16. And what does square root of -16 become? Annabelle, what is square root of -16?
4i.
Mm-hmm. Awesome. And so we can simplify this farther. We know that we can break that up into those two different fractions. -2 divided by -2 is 1. And a 4 divided by a -2 will give us a -2i. Jaden.
Are the only ways you can divide by a denominator if like it can go in, if both terms can go into it? Is that like the only way you can do it?
So like up here in example 1, we could have split it up into 2 different fractions. It couldn't simplify any farther. We can't put that 2 into -7 or that 2 into √73. It's just, but we saw here that we could put -2 into -2 and -2 into 4. So it's just something easier to look at rather than just
Okay, that makes sense. Thank you.
You're welcome. All right, questions?
Do you have to put that sign where the -2i is?
Good question. So since we have this plus or minus here, it's going to be +2i once and it's going to be -2i another time. So that negative is not necessary there.
Okay, thank you.
Yeah. And notice how here we got imaginary solutions, like they said, because we ended up getting that negative inside the square root. All right. So now we're going to talk more about what that means, what the discriminant means. So when that b squared, remember the quadratic formula is x equals -b plus or minus square root b squared minus 4ac all over 2a. And that discriminant, this discriminant is what is inside this square root, that b squared minus 4ac. And that's what you see we are dealing with here, b squared minus 4ac. So when that b squared minus 4ac is greater than 0, what you get inside that square root is positive. You will get 2 real solutions. That means you have 2 x-intercepts because that's what we're solving for here. We're solving for x. When you get b squared minus 4ac equal to 0, you end up getting 1 real solution. And then your graph of that equation just touches the x-axis. It has that 1 x-intercept, so it's going to touch it at one place. And then when that b squared minus 4ac is less than 0, you get 2 imaginary solutions, which means you don't end up having any x-intercepts there because they're imaginary. And we saw that right on the previous page. When our b squared minus 4ac was greater than 0 in example 1, we got 2 real solutions. When that discriminant was 0, we ended up getting 1 real solution. And then in example C, we got 2 imaginary solutions because that number inside the square root was negative, and whenever we take the square root of a negative, it's imaginary. So now that kind of ties it all together. This is your little cheat sheet to use. So now let's find the discriminant of these equations. And they're telling us to give the number and type of solution. So let's start with A. We know our discriminant is b squared minus 4ac. So we are going to just write b squared minus 4ac. So for example, A. What is our B and what is our C? Ella, what is our B in example A?
The B is 6.
Yeah, and what about C?
The C is 5.
Awesome, 5. So now we are going to take that b squared. We said b was 6, so we have 6 squared minus 4. I forgot about A. Ella, what's our A here?
1.
Yeah, good. Minus 4ac. 6 squared gives us 36. Minus 4 times 1 times 5 gives us negative 20. So we end up getting 16. So down below for A, our discriminant was 16, which is greater than 0, right? That 16 is positive. Alyssa, what does that mean? How many solutions do we have if our discriminant is greater than 0?
2.
Yeah, 2 what? What type of solutions?
Real solutions.
Yeah, 2 real solutions. So go ahead and try B and C using the discriminant. That b squared minus 4ac. Gabby Soul, what is negative 4 times 1 times 9? In part B here.
Negative 27.
One more times 9 or plus 9 again.
Wait, 4 times 9 is 27, right? Or is it?
Yeah.
Hold on. 36. Sorry.
You're good. So then 36 minus 36 is 0. How many solutions do we have for B then? Gabby Soul, how many solutions did you say you had for B?
1.
What type of solution?
1 real solution.
Yep. That matters whether it's real or imaginary. You want to be specific there. Awesome. So then when we do C, we get 6 squared minus 4 times 1 times 13. And Jordan, what did you get for 4 times 1 times 13?
Negative 52.
Good. So then this ends up being negative 16. So we know that negative 16 is less than 0. It's negative. So then Jordan, what type of solution are we going to get for C?
2 imaginary solutions.
Awesome. So the discriminant helps us determine how many solutions and what type of solutions we're going to get. Okay. Questions? All right, let's go on to the last page here. There's 3 practice problems. They're asking to find the discriminant and tell what type of solutions we're getting. So go ahead and try these 3. With remembering the discriminant is b squared minus 4ac. I'll give you a minute to do that. Valeria, what did you say A, B, and C are for number 1? It's okay if you're not done.
-1, 2, and -1.
Awesome. So when we plug this in, we get 2 squared minus 4 times -1 times -1. So then we get 4. And then what's -4 times -1 times -1?
-4.
Yeah, which is 0. So what type of solutions are we going to get here?
1 real solution.
Awesome. Leah, what did you say A, B, and C are for number 2?
I said A is 1, B is 6, and C is 4.
Awesome. So then we get 6 squared minus 4 times 1 times 4. So then this is 36 minus what?
16.
Yeah. And 36 minus 16 gives us?
20.
Yeah. So what type of solution are we going to have for 2?
2 real solutions.
Yeah. Because 20 is greater than 0. And we know we can take the square root of a 20. It's real. That'll be a real decimal. Good. Julia, what did you say A, B, and C are for number 3?
A is 1, B is 9, and C is -11.
So, is everything on the same side?
No.
Yeah, that one had a little trick in there. So we got to bring everything to one side. Very important step when you're using the quadratic equation or quadratic formula or the discriminant. You need to make sure everything's on one side. So then, Julia, what is our B and C here?
So then our B would change to -9 and then a +11.
Yeah, good. So we have -9 squared minus 4 times 1 times 11, which gives us +81 minus 44, which is 37. Julia, how many solutions do we have for number 3?
Would just be one real solution.
So look at the chart at the top of the page. Or on the previous page, my bad. When that discriminant is positive, that means that number inside the square root is positive. So we're going to have a plus or minus. So we automatically know we'll have 2 solutions, but what type of solutions, real or imaginary?
Would they be imaginary?
Can we take the square root of a positive number? Will we get any imaginary parts of that?
No, you wouldn't.
Right, so this would be 2 real solutions. So this one didn't have any imaginaries. So let's look at that again on the previous page. When your number is positive, you will get 2 real solutions. When it's equal to 0, you get 1 real solution, and when it's less than 0, that's when you get imaginary. Okay. Questions on the quadratic formula or the discriminant? All right, so then you have book homework. And tomorrow we are going to review completing the square and the quadratic formula. So the last 2 ways that we just learned how to solve, we're going to review them tomorrow. Maybe play the quadratic formula song on YouTube while you're doing homework. Just have it playing in the background, have it cemented in your head there. But that is all I have for you today. Have a great day.
Have a good day.
Thank you. Have a great day.
Thank you.
Thanks.
Have a nice day.
See ya.
Madison, do you have a question?
Perfect. Nice job.
Thanks.
I can tell you're more comfortable with those kids now.
Yeah, I'm getting to learn it better.
Oh, that was great. Like pacing was perfect. You got through everything. You were able to go through the homework questions from yesterday. Nobody asked any others. So perfect.